Calculate the standard cell potential produced by a galvanic cell consisting of a nickel electrode in contact with the solution of ionic nickel and silver electron in contact with solution of Ag plus ions. Which one is which one is anode and which one is cathode? So in order to find out the standard cell potential, I'm going to write down the formula for you. That's the standard cell potential. That's going to be equal to standard reduction potential of the cathode minus standard reduction potential of the anode. How do we figure out which one is anode, which one is cathode? Cathode reduction happens, and in anode oxidation happens. Reduction happens where we have more, or let's say stronger, oxidizing agent. It means that when we are dealing with a table which is called standard reduction potential, cathode is above the anode. So let's find out these two elements standard potential, reduction potential. So I'm gonna say nickel. When you find it in the table, the standard reduction potential is negative 0.26 volts. And for silver, we have .8 volt. This one is aqueous, this one is solid, aqueous. So as you see here, silver is greater than nickel. This one is 0.8 plus 0.8, and this one is negative 0.26. So since this one is greater than the other one, it is a stronger oxidizing agent comparing to the nickel. So reduction happens in here, oxidation happens in nickel. So this one is going to be the cathode, this one is going to be the anode. So when we sub it in the formula, that's going to be 0.8 minus negative 0.26 . That's going to be 1.06 volt. So that's the standard cell potential.